In space, nobody can hear you speak, but with the right equipment, it is possible to detect a sound. That's what scientists discovered back in 2006 when they began to look for distant signals in the universe using a complex instrument, which was fixed to a huge balloon that was sent to space. The instrument was able to pick up radio waves from the heat of stars. But what came through that particular year was nothing short of astounding. As the instrument listened from a height of about 23 miles, or 37 kilometers, it picked up a signal that was 6 times louder than expected by cosmologists. Because it was too loud to be early stars and far greater than the predicted combined radio emission from distant galaxies, the powerful signal caused great confusion. And scientists still don't know what is causing it, even today. What's more, it could deal with efforts to search for signals from the first stars that formed after the Big Bang. The name of the instrument that detected the mysterious roaring signal was the Absolute Radiometer for Cosmology, Astrophysics, and Diffuse Emission, ARCADE, which NASA built to extend the study of the cosmic microwave background spectrum at lower frequencies. Cosmic microwave background is the remnant of early-stage space objects. The mission's science goals, as ARCADE floated high above Earth's atmosphere to clear its view free of interference from our planet, were to find the heat from the first generation of stars, search for particle physics relics from the Big Bang and observe the formation of the first stars and galaxies. It accomplished these goals by scanning 7% of the night sky for radio signals, since distant light becomes radio waves as it loses energy over distance. ARCADE was able to make absolutely calibrated zero-level measurements, which means it was measuring the actual brightness of something in real physical terms rather than relative terms. This was different from typical radio telescopes, which observe and contrast 2 points in the sky. By looking at all of the light and comparing it to a black-body source, ARCADE was able to see the combination of many dim sources. It was then that the intensity of one particular signal became apparent, even though over many months. NASA scientist Dale J. Fixson said while it might make a good movie to see us surprised when we see the light meter pop over to a value 6 times what was expected, we actually spent years getting ready for our balloon flight and a very busy night taking data. It then took months of data analysis to first separate instrumental effects from the signal and then to separate galactic radiation from the signal. So the surprise was gradually revealed over months. That said, the impact was still huge. Since then, scientists have looked to see where the radiation is coming from while looking to describe the properties of the signal. The latter became apparent rather quickly. Until now there is debate like one. Is the space roar coming from the Milky Way? People who say this roar isn't from Milky Way has led as they have high proof. All radio signals from a galaxy follow a spatial distribution, but this roar doesn't follow any spatial distribution. So we can say this isn't from the Milky Way too. How the 13-year-old mystery will be solved, of course. There is also the possibility that there has been a coincidence of errors among ARCADE and the other measurements to date that have mismeasured the level of the radio synchrotron background, Single said. This does seem unlikely, given that these are very different instruments measuring in quite different frequency bands. Whatever the signal is, it's also causing issues when it comes to detecting other space objects. As NASA has pointed out in the past, the earliest stars are hidden behind the space roar, and that is making them more difficult to detect. It's as if the universe is giving with one hand and taking with another, but to have uncovered something so unusual is immensely exciting. When you're ruling out an origin from primordial stars and known radio sources such as gas in the outermost halo of our galaxy, it's a mystery any scientist would savor with relish. In order for scientists to finally resolve this 13-year conundrum, more research and evidence is sorely needed. As it stands, there is a debate over sending ARCADE back up given the genesis of new technology, and given its accurate set of instruments, immersed in more than 500 gallons of ultra-cold liquid helium to make them even more sensitive, there would certainly be no harm in doing so. But there are also new projects emerging which could help. One of them will use the 300-foot, 91 meters, radio telescope at Green Bank, West Virginia, to map the radio sky to higher precision than before. SINGL is working on the Green Bank Telescope project, making use of the largest clear-aperture radio telescope in the world to measure the level of the background as a primary, rather than an ancillary goal. It will do this using a definitive, purpose-built, absolutely calibrated zero-level measurement taken at the megahertz frequencies where the radio sky is brightest. A megahertz is equal to 1,000,000 hertz. Anyway, that's all I got for this video. Please remember to subscribe and like the video. Tell me which video you want next.